Welcome to Fresh Thinking by Snowden Optiro. My name is Allan Earl. I'm an executive consultant in the mining advisory team at Snowden Optiro, and today I'm joined by Chris Jones. Chris is a principal mining engineer with Snowden Optiro. He's got 18 years experience in open pit and underground mine planning, and I will be speaking to Chris today about the mine planning process. Chris, can you briefly describe some of the underground projects that you've worked on in your career?
Over my career I've worked throughout Australia, or West Australia and Africa. Recent projects have been some large-scale gold and lithium projects in WA, and have also worked around West Africa and East Africa, and a little bit of South Africa, primarily in gold as well.
Thanks, Chris. Can you describe the general process followed in underground mine planning?
Assuming this is a new project with no recent history of mining, the process can broadly be described in a few steps. So initially we'll be trying to familiarise ourselves with the deposit, so we'll be reading any reports available, discussing things with the authors of those reports if possible, and looking at the drill data and geology wireframes for ourselves, trying to get an overall feel for the deposit. We also have to make sure we have access to all of the current geological resource models, any geotechnical data, any resource reports, hydrology reports, geotechnical reports, and more information on our process recoveries and metal prices.
Thanks, Chris. But what happens when there isn't sufficient data, for example, for scoping studies, for preliminary economic assessments and so on?
Typically in a scoping study, we have to make some assumptions on the data we're using, as some of the more important studies haven't been completed at this stage. Typically this will be geotechnical drilling, as that higher cost drilling hasn't been completed. Usually we could be looking for similar operations to benchmark against, or we'd also be using our experience to determine what would be applicable to apply.
Thanks, Chris. So now you have all the data that you need for the deposit. What then?
So initially we wanted to look at what mining methods would be applicable for the deposit. And generally the first step is looking at the size and the geometry of the ore body. So somewhere around 90% of mining methods will be dropped out at this stage, so we can bring it down to just one or two mining methods that would be applicable. So undertake some preliminary stope optimizations using MSO, which will be based on the stope level, the stope heights, the stope minimum mining widths, cut-off grades, and expected dilutions on generally the hanging wall and footwall. We'll start looking at a variety of cut-off grades to make sure the deposit holds together at a range of values. Typically at a high cut-off grade, the ore body can start to fall apart a bit. Once we've evaluated our different inventories, and depending on what the client is looking for, we'll choose what we think is an appropriate cut-off grade for the deposit.
Thanks, Chris. Cut-off grade selection is quite complex, and that's going to be the subject of a separate podcast, so we won't deal with that today. So assuming you've selected the mining method, the level spacing, the cut-off grade, what then?
So once we've got our selected slope shapes, we'll start looking at some mine design layouts. So generally I look at the ore drive and level layouts initially, so laying out where our ore drives will sit, where the footwall drives, any crosscuts between them, and how it will actually connect to the stopes. From there, I work back towards what the access will be and start putting in access drives and primary infrastructure, such as ventilation, any pumping stations, substations alike, secondary egress. And then with each of the level layouts completed, I start connecting them up from the decline. At our early level, some studies might also look at whether we'd go for a decline or a shaft option.
Chris, so you've done initial MSO optimization runs. Do you feel these are adequate for stope designs, for scoping pre-feasibility and feasibility studies?
So generally, if the stope MSO shapes are generated correctly and with the thought put into the parameters, they're suitable for the level of accuracy of most of those studies. And in general, when you get to short-term planning at the operational level, these will be redesigned to accurately implement the grade control information you'll have available then.
Thanks, Chris. So you finished the design process. You have designed the mine. What is the next step in the mine planning process?
So once we have a design that we're happy with an adequate layout and all of our levels laid out and connected to stopes, we start to set up the mining schedule. So the first part we're generally doing is taking all of our design strings and attributing them correctly, as it makes it a lot easier going forward. So defining what types of activities, what levels, and setting up any derived activities associated with them. With all the activities set up, we then have to go through dependency creation. So if all the attributes are done nicely, we can set a lot of that to be automated rather than manually linking everything together. And that lets us iterate things a lot easier as we come back later and potentially want to look at different stope shapes or altering the design. The dependencies also put in our production delays. So generally we would have a drilling and a loading activity with a delay for blasting in between or something along those lines. Once we have all our tasks linked up to each other, we start having a look at what equipment fleets we're planning on using and the productivity assumptions we're going to use for the schedule. With the equipment fleet, we set up our resources and assign these to the various tasks, which gives us our duration for each activity. So we're basically just trying to replicate the production cycle within the schedule itself. Once we have that all set up, we look at what production targets we might have. So if we're aiming for a set ore tonnage to feed a process plant, or if they have grade targets or limits on total material movements in TKMs, we'll set those as the production targets. And then using a program such as Studio UG, we'll level all the resources to balance the equipment fleet, and then adjust as required.
Thanks, Chris. So we have a design, we have a development and project schedule, and hopefully everyone's happy with it. What are the next steps?
So generally it's used to start developing a financial model from that point onwards. So we're exporting everything out of the software, generally into Excel, and then we can start calculating exactly the the equipment requirements, start putting some costs to our equipment fleet or contractor costing, depending on whether it's a OEM or contractor setup. Then applying all our process factors to look what our recovered metal contents will be and the financials that go along with it to eventually develop a full financial model for the operation.
And if people are not happy with the results?
So generally we'll end up doing multiple iterations. So whether that's going back all the way to adjusting stope shapes from the beginning or changing the design to influence the schedule and achieve a better result, but generally iterating it overall until something that everyone is happy with.
Thanks, Chris. Your explanation of the mine planning process will raise a lot of questions, and we hope that we can answer those in future podcasts. Chris, thank you for your insights into underground mine planning, and hopefully you can join us again in a few weeks and we can discuss underground cut-off grades.
Cool. Thanks, Allan.
If you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you can find them free for use on our website, on Spotify, Apple Podcasts, Google Podcasts, YouTube, or other podcasts. Chris, thank you very much for joining us today.
Cool. Thanks, Allan.